Hey everyone! So in a couple of recent videos, we actually took the integral of secant and of secant cubed. Now in this video, I want to look at, well, how we go about taking the integral of secant to the fifth x dx. Well, I know I could rewrite that as, right? The integral of secant to the fifth is just the integral of secant cubed x times secant squared x dx, right? I really didn't do anything there. I just split it up. But then I create that product, right? I have the product of two things now that I'm integrating. And whenever you have that, a great technique to look at is integration by parts, right? And the integration by parts formula, let me remind you, is right here. The integral of u dv equals u times v minus this new integral of v du. So we want to set up, whenever we do integration by parts, we want to set up our u and then our dv down in the corner. But let's see, I want my dv to be something I can integrate. Well, I can integrate secant squared pretty easily, right? I know that the integral of secant squared is just tangent. So let me let my u be secant cubed. Secant cubed x. And then what is my du? Right? Well, if my u is secant cubed x, this is like secant x all cubed, right? That's what this means. This is secant x all cubed. So it's kind of like blop cubed, right? It's going to be a chain rule here. So the derivative of blop cubed is what? It's 3. You bring down the 3. Blop cubed is 3 times the blop, which is just secant x, right? So the derivative of blop cubed is 3 blop squared, right? 3 minus 1, times the derivative of the blop. And what's the derivative of secant? It's secant x tangent x. Okay, so there's the derivative of secant cubed. Now, I want to do my dv. Well, if my u was secant cubed, my dv has to be whatever is left over, which is secant squared x dx. So secant squared x dx. And then my v, right? If my dv is secant squared, I integrate to get my v. My integral of secant squared is just tangent x, right? You can always check by taking the derivative of tangent and get secant squared x. Okay, so now integration by parts says that the integral of u dv, right? This axis, this diagonal here, secant cubed x times secant squared x dx, u dv is equal to u times v. So what's my u times v? My u is secant cubed, my v is tangent. So that's secant cubed x tangent x, okay, minus the new integral, which is the opposite axis. The v du is always going to be the opposite axis. We set it up this way. So, well, I have a 3, right? There's going to be a 3 here, which is a constant. That can come out front of the integral. So minus 3 times the integral. If we multiply these together, what do we get? We get secant squared x times secant x. That's going to be a secant cubed x, right? And then tangent x times tangent x, which is tangent squared x. Okay, dx. There should be a dx here. dx. Okay. Now, well, I can actually, I think I'm going to rewrite tangent squared. Now, what is tangent squared again? If we look back at our trig identities here, right? Oh, can we even see them? Oh, there they are. Tangent squared is secant squared minus 1. Again, I don't remember that. I only remember sine squared plus cosine squared is 1. And then from that, I can derive anything I want. But tangent squared is secant squared minus 1. Okay. So let's write that in here. So let's have, this is all equal to secant cubed x tangent x minus 3 times the integral of secant cubed x times tangent x, but times tangent squared x, but tangent squared x is secant squared x minus 1. Okay. And then dx. Yep, alrighty. So then let's distribute that secant cubed, and what do we get? We get secant, we still have a secant cubed x tangent x minus 3 times the integral of secant cubed times secant squared gives me a secant to the 5th x, and then secant cubed minus 1 gives me a minus secant cubed x dx. Okay. Well, okay, here we go again. Look at this. Look at this. Look at this. This can be split into two integrals, right? And we have minus 3 times the integral of secant to the 5th, and then we have plus 3, right? Minus 3 times a minus 1 would be plus 3 times secant cubed. Well, secant to the 5th, we have minus 3 secant to the 5th. What do we solve? What is this all equal to? This is all equal to secant to the 5th. So we can just add, these 3, secant to the 5th, to the 1 that's over here, right? So plus 3 here, plus 3 here. That's 1 plus 3, that's 4. We get 4 times the integral of secant to the 5th x dx is equal to what? Is equal to secant cubed x tangent x, and then, right, this minus 3 integral of secant to the 5th is gone. We just added it to that side. That's gone, and we're just left with plus 3 times the integral, plus 3 times the integral of secant cubed x dx. But what is the integral of secant cubed x dx? Well, that takes a little bit of time to evaluate, but we just evaluated it. We just evaluated this integral in the last video. So this integral is actually, it's 1/2 times that whole quantity that we already evaluated. So, and then we know this, and then we want the integral of secant to the 5th. Well, we have 4 of them. So if we just divide by 4 or multiply by 1/4, we get the integral of secant to the 5th x dx. And it's going to equal 1/4 times whatever is in here. So this is 1/4 times what? It's 1/4 times secant cubed x tangent x, and then plus 3 times this. Well, we know what all this is. This is plus, and again, we got a 3 here, which we can probably deal with in a minute. Actually, okay, I'm almost out of time here. I'm just going to end the video right here, and we're almost done, but I'm going to finish up in the next video. So I'll see you soon.